Hello again. Bit of a change today from the stuff with the synthesizer, although this is related, but it's a bit of optoelectronics. It's a switch which is purely light activated. I'm also working in extreme close-up today because the camera really only wants to focus on stuff that's incredibly close up, and I've got to get that sorted. But at least it means you can see everything properly. Here's the switch. Let's find a pointy thing. Here's the switch. It's just a ring of plastic that I actually cut out with a hole saw. And then I drilled two little holes in each side with LEDs in. One of them's green, that's that one, and one of them's red, which as you can see isn't lit. And that's because the red one is acting as a photo detector rather than as a light emitter. This LED over here is just an indicator of the switch state. So if I block up the hole, that's breaking the light beam like this. The indicator goes out. You can see now that the red LED definitely isn't. Oh my horrible fingers! The red LED definitely isn't lit here. It's just a detector. If we take this out again, bingo, the switch is on again. And we can do this as often as we like. I don't know why I'm so shaky. I get nerves when I do these. But something else we can also spot is we can actually it's actually a kind of variable resistor. It puts out a variable voltage just by how much of the light beam is being detected. It's a very simple circuit, and I'll show you how it works. Now, I've decided I'm using an LED as a detector because photodiodes are more expensive and I haven't got any. And if I use this circuit for what I intend to use it for, I'm going to need quite a lot of them, and I don't want to go buying lots of more expensive photodiodes when I've got bags and bags of super cheap LEDs. Now, not everybody realizes that an LED acts as a photodiode. That is, it will produce current if you shine a light on it. So I'll attempt to demonstrate that now. I'm going to have to move the camera, so you will go into a world of blurry. And here we can see my multimeter, which is all blurry. Let's try that. No, doesn't want to know. Anyway, it is visible. Here's an LED which is horribly blurry. There we go. See, I'm still shaking. This is a red LED, and I've got it connected to the meter probes. Now, if I actually point it at a, you can see the what the webcam's doing. It keeps zooming past the correct focus point. But anyway, if I point it at a light source, you can see that the voltage on the meter goes up, and if I move it away it goes down, and if I move it back it goes up. Now that's actually quite a lot of volts. You've got a volt that you've got, well, 1.2 volts, something like that. 0.9, 0.7. So it seems like it's producing quite a lot of power, but it's not. It's producing a very, very small current. And while this is acting on the same principle as a solar cell on your roof, it's not going to do much to cut down your energy bills. The reason the voltage is going so high on here is because the current is very, very low, but this has a very high input impedance, or resistance in this case, of at least 10 mega ohms, 10 million ohms, which means if we remember Ohm's law, the current is about 0.1 microamps, or about 100 and something nanoamps at best. And that's not enough to drive very much. So we have to buffer it somehow. Now, one way to do that is with a transimpedance amplifier, as it's called, which is a circuit around an op-amp. But op-amps are relatively expensive, so I'm using a simple transistor. Let's try and get some focus back. No, doesn't want to focus. There we go, which is this transistor here. and that's acting as a buffer. And again, as you can see, actually just blocking that a little bit with the LED on I'm using at the moment, that's enough to affect the output here. And yes, I am using a skewer as a pointer, cookery fans. So let's have a look at the circuit. Now this is in LT Spice, which is a circuit simulator, which you may be familiar with if you're into electronics. If not, it's a really handy tool because it allows you to simulate a circuit. I've got to waggle my mouse over here now. Now this is representing the LED, the receiver LED, but because you can't really do that easily in Spice, what I've done is just use a current source, which is producing about a bit over 0.1 microamps. I've actually set it up to turn that on and off to simulate switching. This transistor here is the buffer, and as you can see, the LED is just strapped across the collector and base. Now, how a transistor works is it's a current controls a greater current. The current through the base is multiplied by the gain of the transistor. So in this case, if we've got 0.1 microamps coming out and we had a gain of 100, that would produce 10 microamps here. Oh, whoops. I touched my wheel. That would produce about 10 microamps coming through the transistor if the gain's about 100. It's higher than that. I'm using a 2N2222, a 2N3904. Let's start again. A 2N3904 actually has a bit higher gain, but I haven't got any of those. This resistor here is there to pull the output down to 0 when there's no current flowing. You have to have a high value because otherwise it will suck all the current and there's none, and it'll pull down too easily. Without the transistor, you would still need a reference resistor here, but then you'd need something like 10 megohms, the same as the meter. So this is acting as a current amplifier effectively. After that, that just goes to another transistor which switches this LED on and off, which is the indicator. It's a fun little project to do because it's very simple to make. You don't need to make this ring. I just did it, so I've got something to shove the LEDs into. And there's one other thing that people may not realise, which is that as a photodiode, as a receiver, an LED can only receive shorter wavelengths than it would transmit as an emitter, as an emitting diode. So that's why this is red, because the green light from here has a shorter wavelength. If you use a green LED as the receiver, it's much, much less sensitive. And a blue one wouldn't work at all. If you were to have a blue LED here, then a green one would work better there, and so on. And if you had an ultraviolet LED here, then blue would work there. Are there ultraviolet LEDs? I don't know. Probably by now. But that means that the red is your best option. Now, the even better option, if you've got any, is an infrared photodiode, but I haven't got any of those. The advantage of doing this is that I want a switch that doesn't require being tactile and clicky, and the advantage of an optical switch is there's no contacts to get dirty either. You can keep shoving things in and out your hole until the cows come home, and it will never get all clicky and scratchy. And the reason is I'm looking into actually fabricating a simple, not high quality, but a simple, cheap actual music keyboard. as a MIDI controller, maybe to build into the synth itself or separately, simply because I haven't got enough keyboards and I can't afford any. But I have got lots of bits of plastic hanging about, like this one, for instance. This is a bit of black acrylic. So that's why I'm doing it. Anyway, that's an optical switch. I probably should say something else, but I can't remember what it is, other than to say, if you like this, please subscribe, hit the like button, and please comment and tell all your friends, tell random people in the street, tell everybody, write to your MP.